Hello. So this problem requires you to solve for the area for this entire figure. So what we're going to do is we're going to break this figure into a few triangles here. So I'm just going to draw a line down here. So first you have this triangle A and this triangle B. At the end, when we're finished, we need to use the area. Area equals base times height. The base, we already have that. That's 75. But the problem is we don't have the height. The height it has to go straight down in a perpendicular fashion. We have a slant. So this over here I'm going to call it a slant. But we can't really use this in our formula for base times height for a parallelogram. So let's redraw triangle A over here. So here you have triangle A. So triangle A. So and here we'll call this triangle B. Okay, so we already know some parts of this. So for example, here it says that this whole length here is 75. So this means that this length over here for triangle A is going to be, let's call this part X. It's going to be 75 minus X. This length here, this height that we'll eventually need, we'll call this part Y. So this part's Y for A. It's also Y for B as well. And then X is over here. So that's X. Okay, so from here, we're going to use Pythagorean theorem. So that's when you have a squared plus b squared equals c squared, where c squared is the hypotenuse. So you're going to get, so c squared is 70 squared equals y squared plus 75 minus x squared. So I'll put a bracket 75 minus x squared for now. So for this other triangle here, triangle B, we have 70 squared equals y squared plus x squared. So what you'll notice here, you see that there's a y squared on one equation and a y squared on the other equation. So we can actually use this to substitute one into the other. So I'm going to move the x squared across the equal sign. So you're going to get 70 squared minus x squared equals y squared. So all I've done is I moved the x squared across. So remember, all of this is equal to y squared. So we're going to substitute this whole section into y squared. So I'm going to continue the calculations down here. So 70 squared equals, so y squared is now 70 squared minus x squared. So I'm going to write 70 squared minus x squared. So here, you'll have to expand. So if you have 75 minus x squared, this means you're going to do something that looks like this. 75 minus x, 75 minus x. So here 75 times 75 is plus 5,625. X times 75, negative x times 75 gives us negative 75x. So negative 75x. 75 times negative x gives us negative 75x. And here you have negative x times negative x gives you positive x squared for now. So from here, what we'll do is we'll start to cancel out some of the variables. And when we do this, we are going to so here you have negative x, and here you have positive x squared. So these two will cancel out. Here it's 70 squared if you bring this across equal sign and turn it to the negative 70, or since they're both on different sides of equal sign, you can cancel those out as well. So now what you have left over is 5,625 minus 75x minus 75x, and on this side you have 0. So here you can simplify further. You can bring, it doesn't matter which one you bring across, but let's say you bring across 5,625, it's negative. Negative 75 minus 75 gives you a negative 150 x. Divide by negative 150 to isolate for x. Divide by negative 150 to isolate for x. So from here, you will get x equals 75. X equals 37.5. All right. So from here, you can plug x back into your original one of your triangle A or triangle B to solve for y. If you do this, you're going to get 70 squared minus 37.5 squared equals y squared. So 70 squared minus 37.5 squared, square root of that, you get y equals 59.1. So great. So now you have y equals 59.1. So that's perfect because here, this is your height. This is 59.1. And your base you already have as 75 because it says right here 75. So that means that the area for this parallelogram is going to be 75 times 59.1. 75 times this gives you 4,433 centimeters squared. Now, keep in mind that I didn't use significant figures or significant digits in these calculations, and I also don't know how many decimal places your teacher wants, but this is one way you can use to solve the problem.